friends, and welcome to another online learning video. Today we're going to be talking about word problems, specifically addition and multiplication word problems, and how to tell them apart. So our objectives for the day are, I can differentiate between addition and multiplication word problems. This word right here, differentiate, means to tell the difference between. Right here means to be able to tell the difference between. And our second objective is I can identify keywords within addition and multiplication word problems. Identify means to find. So you'll be able to look at a word problem and find the keywords. So speaking of keywords, we need to make sure we know what they are before we start looking at our word problems. So for addition word problems, the keywords that you should be looking for are in total, in all, altogether, more, combine, both, get, sum, join, and add. And remember, with addition, you have two or more groups and you're putting them together. That's what's happening. Multiplication, your keywords are in total, in all, altogether, each equal groups of rows twice, which means two times, times, and multiply. And what multiplication means is that, again, you have two or more groups, but this time the groups have to be specifically equal groups. So you have two or more groups of the same size, and you're combining them. So those two actions are very similar, which is why we need to talk a lot about how multiplication and addition relate to each other. So again, this slide basically shows in picture form what I just said. So this first picture shows three equal groups of four. So remember, when we're multiplying, we're going to have two or more equal groups and we're combining them. We're putting them together. And so the first number in our multiplication equation is going to be the number of groups we have. The second number in our multiplication equation is going to be the size of each group, so how many is in each group. And then, of course, the number after the equal sign is the total. So remember, you can also read the multiplication equation as groups of. So this time symbol, instead of saying times, you can say groups of. So we can read this as 3 groups of 4, which is exactly what this picture shows us. This comes in handy when we see a multiplication equation that we don't know how to solve. We automatically know what picture to draw to match it if we just read it the groups of way. On the other side here, we see one group that has 3 and one group that has 4. Now, I can't solve this picture, meaning I can't find the total number of x's here using multiplication because these are not groups of the same size. I do have two groups and I do want to put them together, but since the groups are not equal, that means I'm adding and not multiplying. So we have 3, which is our first group, plus 4, which is our second group, to find a total of 7. So let's look at this in word problem form because that's what we're doing today. So problem number 1, Miss Sullivan is buying donuts for her students. She buys 6 boxes. Each box has 8 donuts. If she teaches 45 students, does she have enough donuts for everyone? So when you have a word problem that asks you if you have enough, the first thing you need to do is figure out how many you have. So for now, I'm just going to ignore this last part. I'm not going to look at it yet, and I'm just going to look at the beginning. So, Miss Sullivan is buying donuts for her class. For her students, she buys 6 boxes. Circle my numbers. Each box has 8 donuts. So I want to find how many I have in all. The keyword that I see here is each. Remember, each is one of my keywords that lets me know that I could be multiplying. And another way that I know that I'm multiplying is that if I have 6 boxes, meaning 6 groups, and each of them has 8, that means I have 6 groups of 8, or 6 equal groups that each have 8 in them. So that means that I could either draw 6 circles, and inside I could either put 8 little dots, or I could just write the number 8. My pen is a little bit slow, sorry. Along the top here, I can skip count. So 8 is my first. Sorry, before I did this, I should have written my number sentence or my equation. So how many groups do I have? I have 6. My first number is the number of groups times, or groups of, 6 groups of 8. And I'm trying to find the answer. So I can solve this using skip counting, right? So 8 plus another 8, 8, 9, 10, 11, 12, 13, 14, 15, 16, plus another 8, 16, 17, 18, 19, 20, 21, 22, 23, 24, plus another 8, 24, 25, 26, 27, 28, 29, 30, 31, 32, almost there, 32, 33, 34, 35, 36, 37, 38, 39, 40. And then I already know 40 plus 8 is going to give me 48. So here I have 1, 2, 3, 4, 5, 6. 6 groups of 8, which gives me 48. All right, let's look at our next problem and see if we can figure out whether it's multiplication again or addition. Problem number 2. There are 238 people out on the playground. 29 more people come out to play. How many people are on the playground altogether? So I'm going to circle my numbers. It looks like first we have 238 people, then 29 more. More sticks out to me as a keyword, which normally means that I'm adding, right? If you're adding more on. And then I can underline my question. I want to know how many people are on the playground altogether. Altogether is another key phrase that lets us know that we're adding, but it could also mean that we're multiplying, right? Because if we're adding equal groups, then I could solve using multiplication. But let me ask myself, am I adding equal groups here, or are my groups different sizes? So my first group has 28 people, and then 29 more people. Did I say 38? 238. And then 29 more people come out. So one group has 238 and one has 29. Those groups are definitely not equal. So I cannot solve this problem using multiplication. So my equation to solve this problem is going to be 29 plus 200, it's a weird 2, 238. Now I'm going to put these numbers one on top of the other to solve using the standard algorithm. Sorry. 238. And then when I put this number 29 underneath of it, I need to make sure that I put my 9 in the ones place and my 2 in the tens place. So I need to make sure my place values are lined up very carefully. All right, now I'm just going to add these together. What's 8 plus 9? 8 plus 9 is 17. So I put down the 7, carry that 10 over into the tens place. 3 plus 2 is 5, plus another 1 is 6. And then 2 plus nothing is 2, so I just bring it down. So 29 plus 238 equals 267. So that means there are 267 people on the playground altogether. All right, let's look at one more problem. Tanai goes to the store and buys 6 apples. If each apple costs $6, how much money did she spend altogether? So let me circle my numbers. I have 6 and I have 6 again. I'm just going to circle this in 6 because I have 0 cents here. All right, underline my question. How much money did she spend? That's what we're trying to figure out. Now, a keyword that sticks out to me is each. Each often lets me know that I'm multiplying because it means that each group has the same amount, meaning that my groups are equal. And again, if we were to picture this in our brains, right, we have 6 apples and each of them costs 6. 1, 2, 3, 4, 5, 6. These are my apples. Each of them costs 6. Again, if skip counting is too much for me, I could draw 6 dots instead of writing the number 6. And then just count all of the dots all together, but whatever works for you. So now I'm just going to skip count up. So 6 plus another 6 is 12. Plus another 6 is 18. Plus another 6 is 24. Plus another 6 is 30. And then 30 plus another 6 is 36. So 6 equal groups of 6 gives me, I forgot to write my equation again. So 6 times 6 equals 36. Or 6 groups of 6 equals 36. Okay, that is it for today. Thank you guys so much for logging on, and I can't wait to see you in office hours.